Okay, let's start with questions that you have. We went over modules 1 and 2 last week, and you have your um, packet of exercises. Is that too loud? Okay. Um, so anything from your packet, or if you were working on the online problem, anything that you want to throw at me to get us started? You want to, yeah. So if you want to bring your laptop Thursday, or if you just want to email me either through Canvas or Nunez email, my Nunez email, a screenshot of it, that's an excellent way to raise a question for me. And that applies to everyone. If you want to ever send me something to discuss in the next class, you can screenshot it and email it to me. That way you don't have to worry about pulling it up later, but you can certainly show me too. Yeah, I moved some of them, which I'll talk about in a minute. You can, um, yeah, you can generate similar questions. Did you find that button when you were working on them already? Let me show you, and this is useful for everyone, I think, how you can generate similar questions to those you might be wondering about, as well as how can you get it to allow you to practice still if it is past due. So let's look at that. You can open it up again if needed and continue working after the due date. What's that? Different instructors do penalty for late work differently. I usually keep mine at around 5% or less penalty on homework. Um, you don't have to worry so much about that for our summer program, but you do want to pay attention to that in the fall class. What is that penalty for doing late work? Yeah. And the real um, goal here for us is that you're testing yourself and kind of achieving an average of around 70% or more on those test parts, because that is your kind of benchmark for the total assessment at the end. And that's the primary grade for our summer program. Mm-hmm. Yeah. And you can use the homework grades kind of as a guide for, are you going to make, you know, around say 73 based on all the homework that you've done, or maybe you might expect like 80 something. Just use your average on the homework and the test to kind of tell you whether you need to uh, study a little bit more on a particular section, or whether you are in a good place. Yeah, we're going to get there. Um, hey, so let's look at the past assignments first. Good. So click on courses. I think it's this icon right here. Yep. No, this one. Right above. Courses. Pelican Pro. And scroll down for me a little bit on this page. Click here. So this is one of our homework from last week that's currently showing past due and uh, telling me, I didn't make a response or an attempt on these, so it looks like I can't do them. However, I can generate another similar exercise by clicking that practice another. And notice on that one, I can, attempt it and check my work and get feedback on that one. See, that's wrong. Um, Also, if you want to use these items, you can click on request extension, automatic, and then accept. Yeah. And then if I go to my refresh, this page option, once this is refreshed, see now it doesn't have those red marks anymore. I can go back and do some of those. So that's how you, yeah, it will also give you a new date. See, that looks like about 2 weeks from now that it will open it back up for you. So use that to your advantage. Reopen those homework as you need. And gray button for me. You get a module 3. So grades for the summer program are really just based on that final assessment. Making the 70% or more is the goal. But the grades that you see in here can be useful as kind of a proxy for where you're at. So I would use them kind of as your guide. And also just getting used to how it will feel when you're in the class. Canvas is going to update with some grades based on how I have it set up now. And I'm going to talk about that a little more in just a second. Click on create account here and use an email you can easily access when you're doing that. What I have set up for us this week in Canvas to automatically populate into our gradebook are these 3 items that you see over here on the right. I extended for everyone the tests on module 1 and 2 in the online homework software, and then we'll have module 3 that we're going over this week. So what I want you to do after you've done a good bit of practice in module 3 this week is to attempt that test for module 3. You may still be practicing in module 1 and 2. And once you feel like you're ready to attempt the module 1 and 2 test, you can do that this week. Once you do, you will see points populate into Canvas based on those test results. And the reason I have those specifically plugged into Canvas because I think they're your best guide of how you're doing. So that's what we'll see in Canvas, those grades only. All those other sections are more like homework kind of style, and those are not going to transfer over into Canvas, just as a heads up. When you get to your fall class, most of us instructors have it such that everything is syncing over to Canvas all the time. But I want to give you just a very targeted view of what you want to focus on is getting yourself kind of conditioned and prepared for testing on the concepts that we're going over. Okay. Any questions on that for this week? Mm-hmm. Yeah. Mm-hmm. What what course were you in? You were in 1300, but you could have taken 1200 most recently based on your program. And so um, we can talk about that more as we go. What's your program of interest? Yeah. Uh-huh. Okay. And you have looked at curriculum for where you want to go from here, and 1200 will map onto a program. Hmm. Hmm. That's what they have you registered for currently. Okay. Let's, you know, continue to have that conversation about which course makes sense for you. Because we talked about that last week a little bit too. Like some people might want to take 1200 in the fall, depending on does that map onto a program effectively. Hmm. Yeah, yeah. Okay. Well, what we do in here is designed to go hand in hand with either. So either 1310 if that's what you need to do, or 1200. What we're doing here is helping you with that leap going into the fall. So, you- 13, 1300 or 1310 is college algebra, which is very technical. We do everything related to algebra, basically. Uh, 1200 survey of math is more a collection of different math areas that are about 2 to 3 weeks each. So we'll do word problems for a little while, we'll do solving equations for a little while, logic for a little while. It's more of a survey or kind of like a general overview of the math topics is how survey of math works. 1200. Go down a little bit more to where you see central US. Not terribly important. Look in that box. Central time. Right there. Yep. Hmm. And we talked about that a little bit last week. You know, you can always decide at a later point that you want to do the college algebra class and use the 1200 class just for the LPN to start with. Uh, as we get closer to the end of the summer, we can talk more about what I think might be best for you. You can just kind of continue to think about it at this point. You go by Dominic or Dominique? Dominique. Okay, good to have you. Um, so we are not finished necessarily with module 1 and 2 work. So continue working on those if you haven't really gone through all of it yet. I am going to spend some time in today's class going over what you see in the module 3 packet, okay? Related to fractions. And I just want you to stop me at any point if you need further clarification or, um, better description of one of the words, what it means, that sort of thing. Please feel free to stop me at any point. The first section, 3.1a, is about factors. And generally, we can think about factors as numbers that divide evenly into another number. Uh, let's talk about factors more. You have the example on your paper, what are the factors of 48? And we know that every time we look at a number, we could divide it by 1 and get that number back, right? So those will always be factors, 1 and the number itself. So we can go ahead and write those two factors of 48, 1 and 48. Then what I would suggest, if you want to exhaust or get all of the factors, is that you just start going down the list of counting numbers. So ask yourself, does 2 evenly divide 48? And check that in your calculator. Just type it in, 48 divided by 2, we get 24. So those are two factors of 48 as well. Continuing up our list, does 3 divide with 48 evenly? Check it if you're not sure. Go ahead into your calculator. 48 divide 3, I get 16. So it looks like that divides 48 evenly as well. 4, type that in. 48 divided 4, what do I get? 12. 5. Decimal, right? For no nice whole number. 48 divide 5. Let's just look at that number for a moment. 9.6. So factors are things that evenly divide or divide the number without decimal. And so these two numbers would not be considered factors of 48 because 9.6 is not an even or a whole number division of 48. Are we done? How do we decide? Let's go up one more number. What's 48 divided by 6? Get 8. We do that. And then 7, we get, let's see, 48 and 7, 6.8 something. So that is not a set of factors. Notice what's happening now is we're kind of getting to the place where these numbers interchange as far as how high they are. 6 and 7 kind of switching places, 6 and 8 here. This one's lower than that one. So that's kind of how you decide that you have gone far enough in trying to find all your factors. When those numbers start to switch places like that, or the ordering of them changes, then you've exhausted all the numbers you need to. You can stop at this point. Is that clear? So all together, we're looking at factors 1, 2, 3, 4, 6, 8, 12, 16, 24, and 48. Those are all the factors of 48. How do we know which number to stop at? So let me throw that question back at you. If you are looking at this list, can you tell me a pattern you see that kind of indicates for you to stop? Anybody want to offer a reader an idea? So how do you feel about when to stop now? Fine. It's still. Mm-hmm. You you might have stopped here after finding that that didn't work. Yeah. So let's just talk through that again to see if we can clarify the process. We're always looking for that process that we can apply to um, to do things kind of like in a systematic way. And if we get in that habit, that can make other problems a lot easier later. So the system starts with just taking one in the number and then two, just counting numbers. 2, 3, 4, 5, 6, 7. Divide each of those numbers with this. And if it's a whole number result, like we saw here, then those are factors. So that's why we're writing down these numbers. If it's a decimal result, like here, then we cross it out. Those aren't factors. We have to continue on our list 6, 7, doing that same thing, figuring out if they're whole number divided. And we stop once this list starts switching its order. Because if we did 8 right here, that would be a repetition, right? If we did 8 down here, divide with 48, we get 6. So you can do that too. You can go as far as it takes to create a repeated one. And that can be your stopping place. Good question. So you got some practice problems you can try. And we also want to talk about prime factorization. So a prime number is one that only has 1 in itself as a factor. Prime if only 1 in blank factor, the blank being the prime number. So some example here would be 3, right? Because when we start our list, we get 1, 3, we get 2, and when we divide this way with 2, that's 1.5, And then we go up to 3, that's 3 and 1. So we're getting that repeated list there. You see that we've exhausted our options, just like we did over here. We found that the only factors are 1 and 3, or something like 3. So that's an example of a prime number where you can only find 1 in itself as factors of that number. Prime factorization is writing like a product of the prime of a number. Okay? And we're going to do that with the 48 that we talked about earlier. So if we were going to write the prime factorization of 48, let's look at that and kind of how it differs with just writing down all the factors. If I were going to write down the prime factorization, then the thing that helps most is taking out 2, 3, or 5, if possible. In other words, the primes that might occur first with this number. So 2 times what gave us 48? 24. So 48 can be written that way, 2 times 24. 2 is prime, but is 24? No, because we can break it down into other things besides 1 in itself. The system you want to use is to continue trying to divide that number out. So can we divide this by 2? 24 by 2? Yeah, that's 2 times 12. Continue trying to divide out more 2s. 2, 2, and 12. That's 2 and 6. So each step here, I'm basically dividing out, or trying to divide out more 2s. With our 6, can we do that? Yeah. Look at that, and we'll get 3 when we divide 2. So that 6 broken down, 2 times 3. And now as we look at that, the list contains only numbers that have factors 1 in itself. 2 can only be broken down into 1 and 2, and 3 can only be broken down into 1 and 3. So those are all prime. And this is what we call the prime factorization. All of this. 2, 4 times over, and 3, 1. Type that into your calculator, that multiplication, and see what we get. Yeah, just type this in. 2 times 2 times 2 times 2 times 3. Got 4 2's in there? Yeah, 48. So that's a way of checking whether your prime factorization is correct. It should multiply back up to the original number. And another way of writing this would be to use our exponent. Remember from last week, we looked at this written instead as 2 to the 4th power and also times 3. Any questions on that example or anything up here? So 3.1e, we talk about least common multiple. Abbreviated LCM. And the idea with least common multiple is that we want to find smallest number that the others can multiply up to. Let's try one. 6 and 18. Okay. I want to find the smallest number that both 6 and 18 can multiply up to. One way that we can try this process is to write down all the multiples of 6 and all the multiples of 18 separately and see where they might match. So if I were going to multiply times 1, then I would get 6 or 18 for those two numbers. Times 2 is 12, 36, times 3 is 18, and 54. And when you find that there's some agreement between those multiples that you've written down, then you can stop. Down to 18 there. So the least common multiple of 6 and 18, it is 18. Any thoughts on that? Any things that you would add to what I just said? Yeah, like this number over here times this number. So 6 times 1 for 6, 18 times 1 for 18, 6 times 2 for 12, 18 times 2 for 36. Yep. Mm-hmm. And so what we found was that both 6 and 18 will multiply up to 18, and that's the lowest of their potential multiples. 1 times 18 gets us there, and 3 times 6 gets us there to that 18. What about with 6 and 9? 6 and 9 times the 1 times the 2 times the 3, and we found a match, right? 18 there. So those happen to also have an LCM of 18. They're the lowest number that both of them will multiply up to. Once you find that match, yeah, then you found your least common multiple. Now you might find other common multiples if you continue on down the table and miss the least one, right? If we kept going, uh, 6 times 4 is 24, then 30, then 36. 9 times 4 is 36. So notice they have other multiples, but that's double the least one. So yeah, you're getting ahead with common denominator. And when we look at common denominator, it's actually okay if you use a common multiple that's not the least one. Sometimes it's easier to just multiply the two numbers together, get 54 in this case. That's a common multiple that could potentially be used as a denominator if you feel like you don't have time to identify the least one. Yeah. I'm glad that you mentioned that. Why are we doing this? Because it's important when we deal with denominators to have this kind of strategy down. Let's look at greatest common factor. Also with abbreviation GCF. Greatest common factor is a factor paired and highest one. So of all the factors between two numbers, which ones do they share, and then which one is highest, okay? So let's try to find the greatest common factor of 12 and 20. Remember our process for finding the factors started with 1 in the number, and then 2, 3, 4, 5, 6, down the list. Divide 2 and we get 6. Divide 3 and we get 4. Divide 4 and we get 3. So there we're getting that repetition. We don't need to continue there. We've got all our factors of 12 going right here. And then 20, same process. 1, 2, 3, 4. 1 divides, 2 divides for 10, 3 decimal, 4, we get a 5, and then if we divide 5, we get a 4. So there's that kind of loop back in our list. And we can stop at that point. Now, to simplify your analysis between these two, I might just kind of come back in my work here and just take this off so I don't have to like deal with that extra. I don't need to have 4 and 3 like in my memory space, right? Likewise, I've got all my factors listed here and this one's repeated. So take this one out. Also, this is not a list of factors right here, right? 3 did not divide 20 evenly. So it's simplifying what we're looking at there is the idea. And now which common factors do we have? Which factors do they share? We've got a 1 that shares 2. 3 is not. 4, like that shared, 6 no, 12 no. So I just kind of like went down this list all the way through and asked myself, is it over there in the factors of 22? 1, 2, and 4 were also factors of 20. So which one's the greatest of those is our 4. That's the GCF. Greatest of all the factors common. Greatest common factor, 4. So I want you to just take a moment and see how the strategies differ there between finding a least common multiple. You have to scale up the numbers, find their things they multiply to in order to identify that least common multiple. Whereas to find the greatest common factor, we're breaking the numbers down into the factors. Any question on either of those ideas before I continue? Yeah, you're breaking down by division on the finding of the factors, multiplying up to find the multiple. Yeah. Recognizing those ways of starting the problem or starting to figure out what it is you're going after is important. So those kind of simple cues of how do I start, those are important. Let's look at 3.2a next. Starting to use some of these things with fractions so we can get nice and comfortable with fractions. And with fractions like 2/3, we are often going to use the terms numerator and denominator. So just a quick kind of refresher on what we mean when we say those words. Numerator is the one on top, denominator is the one on bottom of a fraction. When we say a fraction is proper, the top number is less than the bottom number. So top value less than the bottom value. And just as well, we could put these terms in there, right? The numerator value is less than the denominator value. Improper would be the opposite, like 7/2. The numerator is larger than the denominator. Let's sketch out what both of those examples look like. I mean, so if we wanted to model some thirds, we would divide whole into 3 pieces. That's cutting it into thirds. And then if we want to represent 2 of them, then that would be like having this piece of the pizza and this piece of the pizza. 2/3 of that whole. So we can do that with one either kind of, what do we want to call this? Candy bar versus pizza. So a candy bar we can split up into thirds just as well. There's 3 pieces on that candy bar, and I want 2/3 of it, and there I go. With improper fractions, I need more candy bars or more pieces. I can't model them with just one. So what I would say, I'm going to stick with candy bars moving forward. I'm going to look at one of them and split it in 2. And then I'm going to count how many of those divided into 2 I have, how many pieces are represented there, 2. 2 halves so far. So then I need another candy bar. And now I have 4 halves. Not quite 7 yet. Right? Another one, 6 halves. Another one, 7. If I did more, I'd have 8 halves. So there's my 7 halves modeled with the candy bars. Let me just do this with the pieces too. All of those on your worksheet are modeled in this way, but I show you this way too because I find that to be easier to cut up a bar rather than a pie all the time. So you use whichever one makes more sense for you. Let's cut these pieces into halves, and then 1, 2, 3, 4, 5, 6, 7 halves. We have modeled there with the pieces as well. Then let's go the other way. So let's do, and I'm looking specifically at number 2 on the worksheet if you want to look along with it. It has a pizza divided up in this way. And so before we even look at the how many slices, what's my denominator? Yes, what is it in this particular example? How many? 8? Is everybody on board with Sharita? So we would use 8. Looking at this one. 8. Count all those pieces. That tells you how you're dividing up your whole, and that's the denominator of the fraction. Now for number 2, if you want to look along here, it says this slice, this one, and this one have been taken out, and that's 3 of them. So numerator is 3. For one like number 3 here, we have a whole pie shaded, and another one cut up in the same way, 8, with looks like 5 of the slices. So we need 8, and we got 5 from this one. How many slices in terms of 8 of them does this one have? All of them, or all 8 of them. So to figure out the whole number of numerator digits, we need 8 slices counted here, 5 slices counted here, and so we've got 13 slices total going on. So use those examples to help you situate yourself on the others, on the worksheet, and also on your online modules. let's switch gears a little bit here and look exclusively at improper fractions like these and convert them to what we call mixed number. We can kind of see that easily here is 1 and 5/8, right? But what if we're not looking at that? What if we're looking here? You can't look here. Okay, good. Start. 13 divide 8. What's that give us? 1 whole part. And then how much is left over with what? Remainder 5. Right? Everybody following me here? I'm using a lot of like kind of note taking. Yeah, that's good. 13 divided 8 has 1 whole number. If we do it in our calculator, then we get 1 point something. Let me just write that down. That might be helpful later. When you're looking at these, if you did that, it'd be 1.625. So we take the 1 out of that. The 0.625 doesn't help us if we're trying to write the fraction part that's left over. How do we get that 5? Subtract these two numbers. So 5/8 remains. Got some useful kind of stepwise thinking on the example there in 3 2b. I just want to do at least one more here, maybe a couple more. Try this one. We've got our picture model, right? We can look at this and see that it's 3 and 1/2. So let's try to kind of cement this system and verify we get the 3/2, like we see. 3 and 1/2. 7 divided 2 for what? 3.5. Yep, 3.5. How do I figure out that there's 1/2 left over here? Kind of put to the side that we know 0.5 equal 1/2 for a minute. How do we figure out that the remainder is just 1 right here? This 3 and 2, that's 6, right? So it's kind of like we're coming up to 7 at the 6th level, and 7 minus 6 equals 1. So 3 and 1. Looks like I'm drawing a football diagram, and I don't think any of us want to see that. So let me try to clarify this a little better. This whole number that you get can be thought of in conjunction with this to figure out what the remaining piece is. Divide these two. divide them right, the whole part, 3. Right? Then multiply by denominator and subtract from the numerator. So this thing multiplied by the denominator, 3 times 2. Subtract that from the numerator, 7 minus 3 times 2, 7 minus 6 for 1. And then place that result over the denominator. 1 half. And finally, pair them. 3 from part 1 and 1 half that we got from these 2 steps. That might be overkill. You be the judge. You might see in everything that I did just now a simpler way for you to get there. I just did a bunch of different ways, kind of. Anybody need clarification or some additional discussion you want to have on what method you would use to get there? With that? Mm-hmm. Yeah. Mhm. Yeah. And some of those stories that you're sharing, thank you. I like to get that perspective. I've been at both points. I've been at those places where the next class I took was elite, and I had to figure it out and quick, else I was gone. And at some point, I felt like I was a goner. And I just sat around in the class until the end of the semester, got a D or a C. If I got a C, then I was just fortunate enough to move on to the next class. Then in other situations, I came into a class, I'm like, I've seen this. And some of you may feel about that way about some of what we're doing here, but just kind of look at it. Repetition is not a bad thing for some of this stuff. Let's go the other way of what we just did. So we took this improper fraction and went to the mixed number. Let's take that mixed number now, go back to the fraction, and maybe that'll help us kind of clarify some of that. If we want to take the mixed number to a fraction, then we, as step 1, do the whole part times denominator, which is 2 times, I should write it in the right order, whole parts 3 times denominator 2 equals 6. Then add the numerator with our 6, add the numerator 1. That gives us 7. And then we place over the denominator. 7, denominator 2. So we got back to our improper fraction here of 7/2. Basically kind of go in the opposite direction. So maybe some of these steps help clarify why we did some of what was over there. And so you can work back and forth between those like number 1 and 2 and those like number 3 and 4 on that section, 3.2b, which we kind of started in this process from A. Use those to kind of go back and forth to help situate this system in your head. Let's talk about scaling fractions. And when I say scaling fractions, some fractions might have numbers that share factors and can be reduced. How many of you have heard reduce that fraction, the simplest form, or reduce? So we'll do some of that. And then we can scale in the other way. We can kind of inflate a fraction. We can multiply the top and bottom by the same number and get the same fraction, and that's scaling it to some different numbers. So we can scale down, we can scale up. Let's look at that. And this is 3,3a. Writing a fraction in simplest form. So dividing out common factors is the objective. Let's take, for example, 12 over 40. How can we write 12 with, say, next factor from 1? So not 1 and 12, but something else, like 2 and something, or 3 and 4, I heard. So just try something. Then try something here that matches with there. So 4 and what gives us 40? 4 and 10. And then we can divide this common factor. So there we have it, 3 over 10. Now, you may not always get there immediately if you happen to go on a different route. Look at me, I'm going Tues and dividing those. But 6 over 20 is not simple yet. I gotta keep going. So 6 can be written 2 times 3, and 20 can be written 2 times 10. And then I divide another set of twos, and I get 3 over 10. To get the same answer, depending on either route that I take. And then let's look at going the other way, which is raising to higher terms. So an equivalent fraction. We're finding fraction that is equal. Another perfectly fine way of saying that, by multiplying the numerator and denominator by the same number. For example, let's take our 3/10 there and write as an equivalent fraction with a denominator of 40. Right. This fraction has something equivalent or equal to it, but with denominator 40. So I look at that fraction and I say, okay, if I want to get it up to something over 40, then how do I scale 10? I multiply it by 4, right? So I multiply this numerator by the same number times 4, and that gives me to 12 over 40. And that kind of a back and forth with the example we did over there. Let's write 18 with a denominator of 8. What's this as a fraction? 18. What is it as a fraction? Whole number 18. This whole number, and we want to force it to be a fraction. What can we do? Place it over 1. So that's how we start operating in fractions with whole numbers if told to do something fraction related. So 18 over 1 is that as a fraction. And we want to write it with a denominator of 8 instead of 1. What do? We do times 8. 1 times 8 gets us 8 for the denominator. And then multiply that same number on the numerator times 8. So that is 146, 44, 144, 144. 8. Yep. We want to scale to a denominator of 8. 1 times 8 gets us there from the 1 we placed, and then multiply the same number on the top, 8 times that, for 144. Okay, it's demanding that we write it with a denominator 8. Yeah, so it's kind of like saying you need to start operating with this as a fraction. So use that kind of general trick of writing it over one to start looking at it like a fraction. That's important sometimes when we have other fractions in an equation and need to bring in a whole number and like add them or multiply them. So we kind of force a whole number to be a fraction. Yeah. And then same goes on simplifying. If we started from 144 over 8, then we can check that just by division and see that it is 18. Or we could do some other route, like try to take a 4 out of here. 4 times what gives us 144? That looks like 36, right? And if I try to get a 4 out of this, that's 2 times 4. So those 4s dividing. And 36 and 2, those share a 2, right? And if you divide everything, like right here, you can assume there's a 1 left over. So that's 18 over 1, just 18. So there's that example going the other direction, starting from something that hasn't been in simplest form yet and going to simplest or reduced form. Okay, we're at time, y'all. So any questions for me on any of those last few things we did? I want you to go home and practice between now and Thursday. We have a couple of more sections in the current packet that we did not talk about today, but you can go ahead and practice those. If you have questions about those sections that are remaining, we can talk about those on Thursday, and then I'll have some more stuff for us on Thursday. You have time to hang out and make sure you're plugged in to Cengage. Hold on just a minute for me. Thanks. Thank you all for coming in today and hanging out with me. I think I have all of you on the sign-in. Where am I signing in? Oh, up here. Yep. Got Sarita, London, Dominique, I'm sorry, and Jackie. Thank y'all. And Jackie, you're gonna get plugged into Cengage. Everyone else okay? And in Cengage? Have you gotten on? Yeah. Okay, good. So practice between now and Thursday. Make note of any questions you want me to go over specifically on Thursday, and I'll see you then. Did you get this email from them at your Yahoo address?
Somebody got to pay it. But I mean,
So check your email one more time. Should come in just a second.
it took a while the whole thing, so.
Click on that one. See you Thursday. A lot of letters.
Capital E and uppercase E, O, lowercase R, C, lowercase D, uppercase T, H. Oh, you got
So you type in your password that you want to use. Twice over.